In recent days, incidents of GPS interference and spoofing have been reported in and around Delhi's Indira Gandhi International Airport. While the Directorate General of Civil Aviation recently asked airlines, pilots, and air traffic controllers to report GPS spoofing within 10 minutes of it happening, the government also acknowledged the incidents in Parliament on Monday. But what exactly is GPS spoofing? How does it affect flights? How is it carried out? And what did the government say in its statement? Let's take a look. GPS interference can occur due to factors such as electromagnetic radiation from devices, intentional jamming, atmospheric conditions, or even solar activity. We all know that electromagnetic interference from devices like radios, cell phones, or power lines can disrupt GPS signals. When there's jamming or spoofing, signals are emitted on purpose to overpower GPS signals. This jamming works by transmitting radio frequency signals on the same frequencies that are used by GPS satellites. Now, what does this cause? Such signals interfere with the original GPS signal and cause disruption in data on position, velocity, and even time of an aircraft. Any interference in GPS signals can result in navigation errors, incorrect altitude readings, or loss of position accuracy. And in turn, this can cause flight deviations, missed approaches, or potential collisions, especially in critical phases such as takeoff, landing, or during approaches in low visibility conditions. GPS spoofing by itself doesn't endanger the safety of an aircraft beyond a point because aircraft systems are built with several redundancies. So, what are the effects like? On a recent flight from Warsaw to Paris, a Wizz Air A321neo was subject to GPS spoofing, which means the aircraft GPS receiver was led to believe it was somewhere it was not. Coming back to the government's reply in Parliament, the Civil Aviation Ministry said that some flights near the IGI airport reported that the GPS signals were spoofed while procedures to land on runway 10 were underway. And for these flights, backup procedures were then used. Flights landing on other runways were not affected because those runways still had traditional ground-based navigation systems in place. It said that the Airports Authority of India has asked the Wireless Monitoring Organization or WMO to try to locate the source of the spoofing. Set up in 1952, the WMO is responsible for monitoring all wireless transmissions and is essentially the eyes and ears of the wireless planning and coordination wing of the IT ministry. Its primary task is to monitor the entire radio frequency spectrum to provide technical data and logistical support to the WPC wing. The government said that at a high-level meeting, the WMO was told to deploy more resources to track down the source based on location details shared by the DGCA and AAI. The government said that to strengthen protection, the AAI is deploying advanced cybersecurity systems for its network and infrastructure. Now, this statement also focused on another important piece of information. It said that the DGCA had already issued an advisory in November 2023 on how to deal with Global Navigation Satellite System or GNSS interference. It said that since the DGCA began requiring reports of GPS interference in November 2023, similar reports have been coming in from major airports like Kolkata, Amritsar, Mumbai, Hyderabad, Bangalore, and Chennai. So, what is this 2023 advisory? What does it say exactly? The DGCA advisory says that the GNSS is a worldwide position and time determination system that includes one or more satellite constellations, aircraft receivers, and monitoring to support navigation. GNSS includes satellite constellations of the USA's Global Positioning System, or the commonly called GPS, Russia's GLONASS, Europe's Galileo, and China's Beidou. It is mandatory for all operators, flight crew, air navigation service providers, and air traffic controllers to report any event of GNSS interference leading to a safety occurrence. While there are no specific flight crew alerts for GNSS interference, it is understood that both jamming and spoofing affect some or all of the applications that use GNSS input on aircraft. At present, it is difficult to distinguish one from the other conclusively based on just impact. Further, impact is also dependent on aircraft avionics and system architecture. And as such, each operator should consult aircraft manufacturers to understand the possible impact on their fleet. On November 10 this year, the DGCA also issued standard operating procedure for real-time reporting of GPS spoofing or interference near the IGI airport. In its three-page circular, the DGCA put in place a system to ensure real-time reporting of interference and spoofing. It said that any pilot, ATC controller, or technical unit detecting abnormal GPS behavior must initiate real-time reporting within 10 minutes of the occurrence. The initial report should have details such as the date and time of occurrence, aircraft type and registration, airline name, flight route, and coordinates of the occurrence or the area affected. Also, the watchdog said the entities should mention the type of interference as to whether it was jamming, spoofing, signal loss, or an error, while also mentioning the aircraft equipment affected. The DGCA has been probing the incidence of GPS spoofing at the Delhi airport and is collecting such occurrences to have a better understanding of the situation. In India, about 450 GPS interference and spoofing incidents were reported in the border region, mostly in the Amritsar and Jammu areas between November 2023 and February 2025, according to the government's estimates. Several airlines had reported that aircraft operating in and around Amritsar have experienced GNSS interference. Airlines have been reporting GPS interference with their flights in different parts of the world, especially while flying near or over conflict zones. Both the International Civil Aviation Organization, or the ICAO, and the International Air Transport Association, or the IATA, have been looking at the issue of GPS spoofing and jamming and looking at ways to deal with them. While aircraft are equipped with redundant systems and pilots are trained to mitigate the dangers posed by GPS jamming, flight tracking data may suffer as a result. Data sent by the transponder in areas affected by GPS jamming may be erroneous, or ADSB data may stop entirely. Flight Radar 24 says that it's working on methods of data collection and processing to mitigate the effects of GPS jamming on flight tracking. Where possible, Flight Radar 24 reverts to tracking aircraft experiencing GPS jamming with MLAT, allowing it to continue to properly plot the aircraft's position. Flight Radar 24 uses various technologies to track aircraft around the world. The main technology, the Automatic Dependent Surveillance Broadcast, or ADSB, sends a wealth of information about a flight, including GNSS position, altitude, speed, vertical rate, and more. For aircraft not equipped with ADSB, Flight Radar 24 uses multilateration, or MLAT, which allows it to compute the position of the aircraft based on the time difference of arrival of the aircraft's radio signals to its receivers. When encountering GPS jamming and spoofing, aircraft that use ADSB are susceptible to position errors. According to a report in The Hindu, an airline pilot said that he encountered GPS spoofing on all 6 days he operated flights in a week in November. During one approach to the Delhi airport, his cockpit systems even issued a false terrain warning, suggesting obstacles ahead where none existed. Such instances caused several flight delays at the Delhi airport last month. The pilot told The Hindu that while it was common to experience GPS spoofing over India's border with Pakistan, such incidents over Delhi were very unusual. According to the ICAO, for several years, instances of GNSS interference and spoofing have been increasing. The current situation is that operational disruptions due to such incidents have become a daily occurrence in some regions of the world. Mitigating the risks resulting from spoofing and interference has become a critical activity for aircraft operators, with few pragmatic options currently available to guarantee operational reliability. And this is unlikely to change in the near term due to the number of conflict zones globally and proliferation of easily accessible technologies to jam and spoof GNSS signals.